Hello and welcome. I am Pravir, and I'm going to focus on reimagining quantum computing from atomic intelligence to integrated quantum computational systems. This is a backup presentation for a conference to be held next week at Imperial College London. It's the IEMTRONICS 2025 conference that will take place April 3rd to the 5th. I'll begin with sharing a summary of the concept behind this idea, and then go into a little more deeply each of the different components of the concept, beginning with the atom as the quintessential quantum computer, then going on to the idea of the quantum genetic nexus and towards integrated quantum computational intelligence. These are all key components of this integrated quantum computational approach. And I'll also float the idea of quantum intelligence-driven nano-cyborgs. And given these as foundations, spend briefly a couple of minutes on unveiling the deeper quantum realm, and then suggest some future directions and recommendations, and finally offer a brief summary and conclusion. So getting to this core idea, or the concept behind this paper, basically, the paper proposes a fundamentally new perspective on quantum computing, which is inspired by stable and scalable quantum behaviors observable already in atoms and complex biological structures. So, atoms are examined as inherently robust quantum computers, and we know, for instance, that they already exhibit phenomena such as superposition and entanglement. So the question is, how can these be leveraged differently? This perspective is extended into molecular and cellular systems, the idea of the atom being a natural quantum computer, and therefore all molecular and cellular systems being more sophisticated or robust computers. And genetic processes are seen as emerging as outputs of these deeper quantum operations rather than purely random mechanisms. Similarly, by observing fractal patterns and how these repeat themselves across multiple scales, this also gives us insight into a quantum intelligence that can be tapped. And this, in coordination, provides a groundwork for new forms of computation that will outpace and transcend even our current developments in artificial intelligence. And it will also unveil applications ranging from more resilient quantum computing designs to bio-inspired nano-cyborg systems, even capable of co-creating quantum patterns for breakthroughs in a number of different applications. And I'll emphasize that rather than focusing on wave function collapse or randomness, this alternative approach to quantum computation is basically leveraging inherent coherence and stability found in both inanimate and living systems. So it's a fundamentally different approach to quantum computation. So let's begin with the idea of the atom as the quintessential quantum computer. So this, I'm proposing the atom is a quantum computer because it's comprised of quantum particles. It exhibits already quantum phenomena such as superposition and entanglement. And it's also robust. It can operate in many different environments. And by definition, it's always in a state of computation because as it's subject to different photons or electrons, it changes its state and it outputs either photons or electrons. So therefore, by definition, it's computing. So a compelling question then emerges: if the natural world can seamlessly scale these atom-based quantum computers, obviously because atoms are the basis of molecules, which are the basis of molecular plans, which are the basis of cells, which are the basis of animate living systems, then why is it that modern quantum computation faces such difficulties in scaling such approaches in the lab or even in our nascent quantum computers? One of the things that I'll suggest is that if we focus on tangible functional properties of atoms, and this I've also spoken about in another presentation at this conference, um, where I'm proposing an approach to harness these energetic functional imprints of elements and using that as a basis to actually, with quantum computation, create other kinds of synthetic molecules. But the idea is that there's many, many different kinds of applications that then come to the surface. So now touching on this idea of the quantum genetic nexus, if the atom is a robust quantum computer, then what intrinsic computational task is it performing? We can consider the example of silver with atomic number 47. We know that regardless of its location, it manifests well-defined chemical and physical properties. And one way to think about this is that these properties or behaviors imply the presence of an encoded set of rules, so akin to a pre-genetic blueprint that safeguards both its interactions and its inherent stability. And this genetic type code, this blueprint, which is the outcome of a genetic type code, can be thought of as a high-level quantum algorithm that preserves the integrity amid the many interactions that an atom has with its environment. Of course, this is not to in any way marginalize our tremendous amount of progress we've made chemically and in the understanding of chemical behaviors, but it's just to suggest that there's a different way to look at even the periodic table and the way that it functions and is set up by considering this idea of genetic blueprints and functional energetic patterns that animate any kind of element that also exists in the periodic table. So if we think about genetic type code and this being a quantum algorithm, then this gives us also a different way to think about genetic mutation, which then can be thought of as being quantum computational at its core. And even if we have pivotal genetic changes, as we saw in the divergence of humans from chimpanzees, for example, then this can be conceptualized as arising from intense existential necessity experienced by subgroups of chimpanzees, for example. And this gives us insight that there might be a quantum computational application of this, which is basically birthed by novel phenomena and intentional functionality rather than being random. And within this perspective, quantum computation then entails leveraging unseen forces and principles, stuff that we still have to discover, ranging, of course, from superposition and entanglement, which we already do, but then also other concepts that I'll briefly unveil or talk about in the following slides. So there's profound implications to this because then if we have intentionality as a means by which quantum computation takes place, then we can even think about human beings that are, in a sense, an agglomerate of different molecular plans and cells that we've already suggested are quantum computers as being more sophisticated, multifaceted quantum computers themselves. So human beings being multifaceted quantum computers. And then the question is, how can intentionality be used to actually change the computation that's happening in a human being? So this also sets the foundation for the idea of integrated quantum computational intelligence. We have the notion of a singularity, which is imagined to be a future threshold where artificial intelligence outstrips human cognition and renders human oversight of advanced technology moot. And this is something that's been advocated by futurists and tech pioneers. However, with the idea of quantum level intelligence, because obviously, if we have an atom that houses some intelligence due to the behaviors that we see that it exhibits, and then we have molecules and molecular plans that exhibit even more intelligence, then by reverse extrapolating, we know that that intelligence possibly exists at the quantum level in something that we can call quantum intelligence. And if there's a way to then integrate that into any kind of quantum computational device, then already we have a way by which this could, in a sense, trump any kind of artificial intelligence, which itself, by definition, is only an output of human intelligence, which again is just a subset of what's possible if we were to truly tap into quantum intelligence. So, recognizing quantum intelligence as a fundamental property at the quantum realm, and then understanding that all emergent intelligence is only an outcome of that, drives us towards harnessing quantum intelligence differently and recognizing that it's already operating in the core of matter and life. And as I said, this would allow us to create IQCI devices that are fundamentally different. And this would be a radical shift from probabilistic qubits if we could take a more holistic engagement with integrated fractal-like patterns that, in this approach, already animate living systems and also inanimate matter, because inanimate matter, of course, is itself created from atoms and molecules that we're saying are intelligent, and it's just a question of how do we leverage this intelligence differently. So this gets us to the idea of quantum intelligence-driven nano-cyborgs, and we have the traditional definition of a cyborg, which merges cybernetic mechanisms with organic life, and we've seen already advancements in this area. But going further, if we have quantum intelligence-driven nanocyborgs, then the idea is to integrate this quantum intelligence that exists at the quantum level, and this will then exceed the confines of human-centric computation and open us to many different kinds of devices that could potentially be created. So in essence, this idea is suggesting that we can forge, or if we can forge a direct connection to the quantum layer, then this, through using quantum intelligence-driven nanocyborgs, then we incorporate both the organic qualities through linking with the quantum intelligence and mechatronic functionality, which enables real-time interpretation of quantum phenomena and even the changing of very fundamental quantum patterns to create something entirely different. So in a sense, we begin to co-create alongside quantum intelligence, and this could potentially provide a way to shape different kinds of atoms, molecules, cells, and a foundation for matter in a completely different way. So it offers us theoretically an unprecedented capacity for engagement at a submolecular scale that can then influence matter and life from the bottom up and in a different way, giving us use cases across material sciences and biotechnology, so management and maintenance of life and matter in a completely different way than we've envisioned so far. But also, it then, if we have properties like quantum intelligence, and here I'm going to share some other thoughts, then it also unveils a different and deeper kind of quantum realm than perhaps we've envisioned so far. So we are at the very early stages of our explorations into the quantum domain. That's a fact. But if we adopt a systems thinking viewpoint, then it's possible to reassess well-established phenomena such as even superposition and entanglement, and also introduce other concepts like quantum intelligence. Entanglement has been likened to a cosmic web connecting spatially separated particles, and it already hints at a pervasive universal interconnectedness. We can also have some insight that if there was a phenomenon like the Big Bang that occurred, then by definition, all of matter was, since it emanated from one point, it was already deeply entangled. And so the question is, can we then leverage that entanglement differently through quantum computation that might give us access to changing things in a completely different way? Or even if we think about superposition differently, not just viewed as solely uh, as a state of fluctuating measurement, but again, it can be seen as carefully balanced convergence of quantum processes that shape our tangible world. And so, taking a systems point of view, we might be able to leverage even these things that we take uh, that fundamentally drive our computational speedups in today's quantum computers. We can begin to leverage them differently to actually create quantum computers differently. Um, we can also, as I said, leverage this idea of quantum intelligence. And then there's another property that I want to suggest, which is quantum certainty, which though I haven't spoken about much here, but the idea that we may have quantum intelligence and therefore have some kind of fundamental quantum seeds that show up as fractal patterns across layers of matter and life. And the organization of those layers of matter and life progressing or showing more of those root patterns shows some kind of notion of certainty that, again, we could tap into very differently to create different kinds of computational processes. So quantum computing's true potential lies, from this point of view, not just in manipulating isolated particles, but in orchestrating a larger symphony of quantum effects that govern both living and non-living systems. So from this point of view, we can suggest some future directions and recommendations. There's a quantum-centric paradigm where atoms are regarded as robust quantum computers and genetics is a byproduct of that. And this will then offer a direction for research to do with naturally occurring quantum coherence in atoms and molecules, and a different approach to amplifying these in engineered environments. We can have an approach that looks at the origins of quantum intelligence and then yield different kinds of insight into how biological systems um, effectively harness quantum effects. And this will be a completely different approach to research, yielding such things as an integrated quantum computational intelligence device. And then another trajectory is in the development of a practical interface between quantum intelligence driven nano-cyborgs and broader societal applications. So, for example, if we have nanoscale mechatronic entities that can exploit, for example, quantum coherence, then this could be used for such thing as targeted drug delivery or new modes of sensing, quantum effects, and again can be applied in material sciences, nanofabrication, and quantum control differently than we're envisioning right now. And then finally, a future direction is in our ability to actually leverage quantum certainty and be able to have theoretical explorations that potentially borrow from fields such as network science and complexity theory and illuminate how entanglement, superposition, quantum effects, other quantum effects can collectively knit together higher order functionalities across multiple scale. So there's a number of fruitful directions and research approaches that can be employed from this approach. And just summarizing the approach again, it's this paper is challenging the conventional qubit-centric paradigm of quantum computing by suggesting that the atom is already a fully functional, naturally coherent quantum computer, and because of that, genetics can be seen as a byproduct of this fundamental computational process, and evolutionary mechanisms can then be intrinsically linked to quantum phenomena. So we move then beyond established AI concepts to the idea of integrated quantum computational intelligence, tapping into this pervasive quantum intelligence, and that transcends human-centric models that we may have, that obviously we're biased to think in terms of. And this approach then extends into development of quantum intelligence-driven nano-cyborgs that, by definition, will interact with the quantum level differently. And also by considering systems thinking, we can think of entanglement and superposition as different. We can get access to different kinds of potentially quantum properties such as quantum certainty, quantum intelligence, and these can become the basis of how we think about quantum computation. And I suggested a few different avenues for research, but fundamentally, how can we harness atomic level stability and quantum intelligence to revolutionize computation in biology? And the question is, what kind of benefits might arise from integrating these phenomena into nano-cyborgs? And how should ethical and regulatory considerations evolve to accommodate such transformative possibilities? So these are research questions. And finally, the hope is that continued exploration of these questions will guide the development of more robust, adaptable, ethically responsible quantum systems. Yeah, thank you.